Hello, the internet, and welcome to Open Source Directions, hosted by Quansight, the webinar that brings you all of the news about the future of your favorite open source projects. My name is Anthony Skopatz, your host for Open Source Directions.
Hi, I'm David Charbonneau, and I'm excited to be co-host for this episode of Open Source Directions. I lead development of open teams at Quansight and am based in Durham, North Carolina.
Hello, I'm Matt McCormick, and I've been involved in ITK community for over 10 years since I worked on my PhD thesis in ultrasound imaging. And I work here at Kitware, a collaborative open source scientific consulting company.
And hello, everybody. My name is Beatriz Paniagua. I also work in Kitware, Carver, North Carolina, and I specialize in craniofacial and musculoskeletal analysis, and I develop ITK functions in those fields.
Excellent. Well, we're super excited to have both of you here today to talk about ITK and everything. And as usual, before we dive into our discussion of ITK and some of the great features in the future and where ITK is going, we're going to have our personalization section right here at the top. So today you both have selected the humorous Stack Overflow post section for our personalization. So I think this is the first time that we are actually going to have the Stack Overflow post, so it should be fun. So Beatrice, do you have something that you'd like to share?
I just found interesting that you asked about this because I don't understand how people can follow Stack Overflow. I mean, isn't Stack Overflow something that you stumble upon when you're trying to Google a compilation error? Man, Instagram, Twitter, those are the things that you follow usually, right?
Yeah, that's true. But people do follow the tags and stuff if you're trying to get that 100,000 rep or whatever.
Yeah. Could be.
You should be following on Instagram.
I don't know. You should follow interior design people that are talking about interior design trends, for example.
Yeah.
Work on it.
Yeah. Matt, do you have a Stack Overflow that you'd like to share?
Yes, I did. I did find a nice Stack Overflow question recently when I was looking at solving a problem. It matched my issue, but there was no answer. It turns out. There was a comment, however, that I found pretty entertaining. It said, "Perhaps I would need to apologize for these thoughts, but I find your endeavor humorous." There's also a significant pinch of masochism. By the way, I did not vote you down. So that comment was not very encouraging for me trying to solve my problem. But, I thought it was humorous, masochistic challenges. That's a theme in my life. So
yeah, that's always the worst when I think the only thing worse than that particular discovery on Stack Overflow is when you Google a question that you've had, and you realize you opened the Stack Overflow post like several years ago, and it's still unanswered.
Yeah,
that is terrifying.
That's also just awful.
Yes.
Well, thanks, Matt. And David, do you have?
I do. Well, not Stack Overflow, because the problem is that I interact with Stack Overflow through Google, as Beatrice described earlier. So I did run across this hilarious tweet this week. Someone summarized a feeling that I've often had but couldn't kind of put to words, which is the general way recruiters tend to interact with programmers. Like, hey, I came across your GitHub profile, and seeing as it didn't 404, I think you'd be perfect for this role. And later on, there's some interesting responses. One of them was, same recruiter later, you tell them, hey, you can just look at my projects on GitHub. What's GitHub?
Yeah.
It's good. That's very funny. For my place, mine comes from the Workplace Stack Exchange, and it is entitled, "Coworker asking me not to bring cakes due to self-control issue. What should I do?" This particular post includes such gems as, quote, "I do not socialize with the coworker outside of work hours," end quote. And this isn't a duplicate of, is there an etiquette to bringing cake, cookies, etc. to the office? So I think it's a pretty funny one all around, in that the workplace one is a gold mine for these kinds of humorous ones, I found in general as well. at this point, we're going to go ahead and dive into our introduction of ITK. So the ITK stands for the Insight Toolkit. It's an open source cross-platform system that provides developers with an extensive suite of software tools for image analysis, broadly speaking. In terms of usage and downloads, it's got about 730,000 downloads from sourceforge.net, and the project has recently migrated to GitHub with PyPI and Conda packages as sort of a new development. It's got about 432 stars on GitHub currently. So at this point, we're going to just ask you two a couple of questions and dive into what ITK is. So,
well, why was this project started?
So ITK was started as the necessity to have software capable of analyzing the data collected as part of the Visible Human project. And for those people in our audience that don't know about this, the Visible Human project was a very ambitious initiative to create very detailed, complete, three-dimensional data set of human anatomy. It was composed of thin cross-sectional high-resolution pictures obtained from histology, as well as magnetic resonance images and computed tomography images of both a female and a male cadaver. So the Visible Human Project planning began in '86 in the National Library of Medicine. And the data collection for the male data set was completed in '94 and for the female in '95. And ITK started in '99 as just a support project for this other bigger project. And it was motivated by providing image analysis, powerful image analysis algorithms in the open, not keeping them closed source so everybody could use them and reproduce any results arising from the Visible Human project.
That's very cool.
And just what needs does ITK fill outside of sort of this Visible Human project?
So ITK started that way, but nowadays is one of the most widely used libraries for image analysis. The origins of ITK were in medical image analysis for obvious reasons. The type of data it was aimed to analyze in the beginning was medical scans, but right now has grown beyond medical image analysis and is used in domains beyond that one, including microscopy and remote sensors, material science, and basically anybody that wants to obtain quantitative information from images, any sort of images. ITK's design is very generalizable and very scalable. So the architecture of ITK allows to analyze n-dimensional images. So everything is templated, so you can just configure your algorithms for any sort of dimension. It includes a lot of advanced algorithms like registration or segmentation, which are two operations used in medical images. Medical image analysis, for example, registration will be the task of finding the spatial transformation that aligns two images and puts them in the same coordinate frame for analysis, and segmentation just classifies different pixels or areas of the images.
Excellent.
Are there any alternative projects out there?
There are alternative projects that includes proprietary tools such as MATLAB, Mimix, and Devo Dolphin. But these tools are generally limited in their capabilities and extensibility, and they have poor performance relatively. Mm-hmm. So in the open source community, similar projects include Scikit-Image, ImageJ, and OpenCV. These projects vary in their technology stack, and each project has strengths in particular types of algorithms. But we've been working together with the leaders in these communities, in particular Stefan van der Walt, in the Scikit Image community and Curtis Rudin in the ImageJ community to improve collaboration between these open source projects. So recently, great strides have been made in the ImageJ and ITK projects, in particular to improve their bridge width and the use of NumPy arrays. And now NumPy arrays are a standard way to use data across these different projects: Scikit Image, ITK, ImageJ, OpenCV. And this is a really exciting development. Researchers can mix and match algorithms from the different implementations: ImageJ, ITK, Scikit Image, this way.
That's excellent. How recent is that development? Interesting.
So we worked together at a workshop last year in 2018.
Okay.
And I think more things are going to happen in 2019. So
that's awesome.
Yes.
Yeah, that's great. You've answered a little bit of this, but what technology is ITK built on?
ITK's core is C++, which is helpful for performance and compatibility with a wide variety of computer hardware and operating systems. ITK is multi-threaded. It's templated over spatial dimensions, as Bea was saying, and pixel types. So it supports processing on n dimensions and allows for compile time optimizations.
Mm.
The upcoming version of ITK is also going to support builds across many different platforms. ITK is used on your standard x86 64 architecture and Linux, Mac, and Windows, but it can also be built for other architectures like ARM and PowerPC 2, so it can be used on mobile phones or high-performance computers.
Mm-hmm.
C++ portability is possible thanks to CMake, and this is one of the most popular cross-platform C++ build systems in use throughout the open source and open science world today. It's worth noting that this open source CMake project, now widely used by millions of C++ developers for various projects, was originally started to support cross-platform builds for ITK.
Ah, yeah, that's funny.
Cool.
That's pretty interesting. And are there other languages that interface? Obviously, you mentioned NumPy. Or is there?
Yes. So the ITK has great Python bindings, and binary Python packages are now available across all different platforms on PyPI or CondaForge. And there's bridges with NumPy data structures, array views, and copies to arrays, NumPy arrays. What's up and coming is the JavaScript support. So you can build the toolkit into WebAssembly and use it from JavaScript. So that's kind of an exciting new development. That's the future of the project.
Cool. Yeah. Well, I'm sure we'll get back to that a little later in the webinar here. So.
Yeah, I've got questions. So who started ITK?
ITK was started in 1999 by Dr. Terry Yu, the project manager at the National Library of Medicine for the Visible Human Project. And Terry Yu is a strong advocate for open science. And so from the project's beginnings, a tradition was started to operate according to the principles of open science, which means open source, open data, and open access to literature. Project participants from the beginning, such as Will Schroeder from Kitware here, Luis Ibanez and Stephen Elward, who are at the University of North Carolina, Chapel Hill, and then they moved to Kitware, Bill Lorenzen at GE Corporate Research, Ross Whitaker at Utah, many, many more who participated in the project were strong advocates for open science because of the need for reproducible research. Literally hundreds of researchers have worked together, contribute to the project, and these principles of reproducible research. Today, ITK and the community continues to operate as a vibrant project that seeks to advance the practice of image analysis through open science.
Yeah, that's excellent. Who maintains the project?
So right now, majorly Kitware, this open scientific computing company that Matt and I are part of, as well as the community, the ITK community. ITK, as you guys know, is developed in GitHub in an open way, and ITK developers try to enforce practices that produce high-quality software. So since recently, we are using continuous integration testing and code reviews that ensure the code is generalizable, fast, is well written, and it will be able to run across many different platforms. And it also ensures everybody is working in their algorithms and documentation along those algorithms. So to help the community, we also, since recently, last year, we have a discourse discussion forum and a mailing list that is a little older than 1 year, but yeah, it is. If you see that mailing list and that forum, you see that the community is really thriving right now. And then Kidware in particular, we use and support IDK because it helps us serve our customers better. I mean, it's really great.
That's awesome.
You mentioned the thriving community. Can you talk about where users and contributors are coming from?
The users and contributors, they vary from university researchers. There's many university researchers to government laboratories to commercial companies. So if you look at the work published at Medical Imaging, Computer, and Computer-Assisted Intervention, MACI, the MACI conference, which is among the largest and most well-respected image analysis conferences, most of it uses ITK. Most of the publications there use ITK in some form. And since ITK has an Apache 2.0 license, which is friendly for commercial development, it's used in the development of commercial projects too. So at Kitware, for example, we help medical device manufacturers develop software for the devices.
Right, based on ITK, right.
Oh, that's awesome. Yeah, didn't know that. And for our last question today, is ITK participating in any diversity and inclusion efforts?
Yes, it is. So one of the main forms of that is through the Insight Software Consortium, which is an organism that provides governance for ITK. The Insight Software Consortium is a nonprofit educational consortium dedicated to promote and maintain open source and support freely available software for medical image analysis. I mean, not only medical image analysis, as we said in the beginning, image analysis in general. And the Insight Consortium holds, for example, the copyright of ITK. And members of the Insight Consortium always keep diversity in mind. Recently, the consortium held elections, and a lot of women were elected to the board. Myself, Ipek August, and Lauren O'Donnell. Myself and Ipek and Lauren are all individuals that have worked towards increasing participation of women in scientific computing. I mean, I think it benefits everybody. For example, I participate in events that encourage STEM training at the early stages in high school events or middle school events. It's really easy thanks to all the ITK tools, including what we are going to show in the demo, Python and notebooks and all these interactive tools for programming. And then also, in events that promote retaining women at different levels in their career. We think women are perfect for the open source community. I mean, there is a growing volume of literature that shows how women are generally more prone to be team players in collaborative work environments. And this is exactly what we need for ITK. So if you're a women developer, come work on ITK. We need you.
That's excellent. That's I think your ITK is one of the first projects we've had on the show that has really had a very well defined positive answer here. So I'm very happy that yeah.
Could not be other way.
Yeah. I mean, most projects they have the will to want to do better in this area, but it sounds like you've already got a lot of inertia in that direction. So that's great. At this point, we're going to dive into the demo section, which is always the most fun section. So I believe you all have some, or Beatrice, you've got some demos loaded up.
We already have it up in the webinar. Can everybody see it?
Yes, I believe so.
All right, so we have a Jupyter notebook in which we are showcasing some of the functionality in ITK. The application case scenario we're going to have here is trying to extract bone from a 3D scan, a craniofacial 3D scan. So what you guys see here is Jupyter notebooks have different cells that can be executed real time. Ignore that. But anyways, you can include ITK and NumPy and ITK widgets. So this first cell, we are loading the scan, and thanks to this ITK widget, you can actually interact with the way the scan is displayed in the screen. So what you're seeing there is the intensity histogram, and then we can actually navigate through different slices.
Whoa.
So yeah, you can see like this is a different axis of the scan. And you can also see volume rendering, and this is what I have here in the next cell. This volume rendering tool allows us to provide a transfer function that lets us see through different intensity levels in the scan. So you see, note that the source image includes soft tissues of the cheeks and the skin, and we might want to remove that. So the way we do that is we very easily and very fast, we can put together some more cells that perform a advanced smoothing algorithm that preserves the shape of what the raw data you have in the scan. So maybe it's not noticeable here, but we have performed some smoothing in the input scan, and then we perform a edge image in this smooth in the smooth version of this input scan we had. So again, here, thanks to the ITK widget, we can see it live. We can actually see how this algorithm in ITK, this gradient magnitude recursive Gaussian image filter, allows us to see the most persistent edges in the scan. And then in this new image, the same thing, all the things that are preserved. This is 3D. So this is all performed, is high performance computing in a 3D image. And then we can just quickly also run a 3D region growing algorithm. This is, less than 10 lines of code. And we can start extracting some of these hard tissue structures. This is that are starting to remove the skin, which is what you see here. And you can go on and on. I mean, we could extract the biggest connected component, that which will give us the bone. And also there are plenty of more complex 3D segmentation filters in ITK that can get you to the final result that you want. And then with this segmentation, we can compute a number of things. We could go further along and extract the teeth, or we can check if a patient at 2 different time points have been losing bone, or the effect of treatment, and so on. All of this through Python and Jupyter notebooks.
Wow, that's really cool to see that working.
Yeah.
And for our audience, I would like to mention that this demo we uploaded it in a GitHub repository. So you can access the same scan, and you can run yourself through the different cells, and you can change the parameters and see how that affects the results. And
yeah, so you can, this is, really amazing that this is all just embedded in the notebook. Is there some data server or something that's running in the notebook or on the machine locally, or it's just, you've literally just read in a file and you're viewing it all right there in the same Python process? Is that which one of those is
Right.
Yeah.
It's using just the standard Python Jupyter infrastructure. And what's really nice, it's right, at the demo that Bea pointed to, it runs on Binder. It runs in any hardware that there's no special hardware requirements. There's no special requirements to install other software or
Yeah.
configure other ports, open other ports in the system. So it's just kind of running vanilla software, which is really easy to get started and to get something working,
right,
and have it working anywhere.
Also, I would like to point our audience back to the community support venues that we have. So there are plenty of examples online as part of the ITK documentation. And there is also a very active user forum where people can ask their personal questions or questions relating to their own code or own demo. So very easy.
Yeah.
Get it easier than this.
Excellent. I guess I just have a couple other questions really quickly here. So about how big is this data set that we're seeing?
So the data set that you're seeing is 28 megs.
28 megs, okay. And so if you had special hardware, right, like say most people have a graphics card these days, right? Is ITK able to seamlessly take advantage of that? Or is it really not necessary because the data volume can be handled on the CPU just fine?
That's something that we're looking to address in the future, is improving the GPU support for processing these very large volumes. This is a moderate volume. The medical imaging volumes are kind of moderate in size, maybe 512 cube, but we're also working with other data types that are much larger, 2048 cubed and even larger. And it's helpful to have GPU-based processing, or maybe someday FPGA-based processing. So we're looking at doing that, and also doing it in a way that it can be easily installed and universally installed in a simple way without special requirements on hardware or special requirements for the installation. So we keep it really accessible that way.
Yeah, that makes sense. Yeah, that's one of the big problems with the GPU scientific stack right now. Well, I think that's great. Is there anything else you'd like to show us? Or David, did you have any other questions you wanted to ask?
The one question that popped up for me earlier was when you mentioned that you can interact with NumPy arrays. I started wondering about, do you know of any projects that are using multiple techniques, including ITK? So, for example, moving data to and from, processing through ITK to run through a machine learning model in TensorFlow or something like that.
Yes, that's the most common use case now, and that's what really has a lot of potential in the Python world, is doing some pre-processing with ITK, for example, and then using all these very mature and powerful machine learning libraries that are available in Python. So a typical workflow is that you need to ingest some scientific data. So if your medical data, the medical data is stored in a specific format that's common in medical imaging called DICOM, and ITK can help you read the DICOM images. Then it can help you, oftentimes this data is too large or it's 3D, you need to reformat it to make it appropriate for machine learning algorithm. You may need to pre-process it, you may need to remove reconstruction artifacts, you may need to align images. So if you're doing a convolutional neural network that's working on data sets that they assume that the data is aligned, and so ITK can help you do that registration of those images. It can help you do registration and alignment with labeled data sets so that you can initialize your training data. And all that coupling is possible through these NumPy arrays.
That's fantastic.
Yeah, that's excellent. Well, thank you so much for this demo. At this point, we're going to go ahead and dive into our roadmap discussion. And so we're going to discuss sort of broadly speaking, where ITK is going in the future. We've touched on this, I think, a couple points already, but we'll, dive into a little bit more detail and sort of hear from you where ITK, what the future of ITK is, and for our audience, keep in mind these are places where ITK could use support or would welcome support, either with respect to code contributions or funding, if you're interested in funding these particular projects, and or hiring people to work on these subtopics, right? So these are the locations where ITK would like to go. So with that, Matt, do you want to go ahead and take the first point here?
Sure. The community has a long history of advancing the cause of reproducibility, and we're very proud of that. But we would also like to be recognized soon as a leader in accessibility too,
right?
And making these algorithms accessible.
Right. So what do you could you dive a little deeper into that? So what do you mean by accessibility? Like installation or understanding of what the method is, or what do you mean in particular there? So
exactly. So easy to get started and easy to understand. So making this available to someone who doesn't have a computer science degree or doesn't spend all day on it, Stack Overflow. Before, right? And making the capabilities of these algorithms available to the broader research community and the broader commercial community too.
So
I would like to point out that oftentimes people will, or developers or scientific biomedical scientists will go for a little bit less powerful analysis option just because it's easier to use. And we have that same problem with proprietary software, just like MATLAB. It's easier to use MATLAB than than code in C++. So I think that's where we're going with Python.
I see. Yeah. So there's sort of a pathway to discovery that you want to enable, and folks can choose to walk down that path or not, depending on what their interest and time availability is. So
exactly,
have a learning pathway into some of the details. Well, that's great.
Yeah.
So in practice, this means developing tools like the Jupyter widgets that we're just showing. And Jupyter is just a wonderful tool for teaching and exploring different computational methods. So the Jupyter widgets bring together ITK and the accessibility of Python and Jupyter, and the 3D interactivity that they had demonstrated is really compelling, and it means that we can instantaneously gain insights into what the data is and how the algorithms work and how the parameters interact with the data. So
is this motivating some of your intent to take ITK to WebAssembly?
Yes, yes. So WebAssembly 2, that's even another kind of quicker step to understand how a computational method is working by absolutely not installing any software at all, or even starting up a Binder instance, just going to a web page and interacting with the data, seeing what the data means, and seeing what a method or algorithm means when it interacts with that data.
So in terms of accessibility for that, I'm kind of curious there. WebAssembly and some of these data sets can get quite large, right? So even if you're going to a web page, it could end up being, hundreds of megabytes to download that single web page. And so I wonder, in terms of accessibility, are there thoughts about how you might mitigate some of those problems with respect to people who are on low bandwidth, in low bandwidth scenarios, I suppose is a nice way to.
It's a good question. There's definitely trade-offs, and trade-offs that need to be handled here. And this is something that we dealt with a lot with the Jupyter widgets, was sending data across the network, because the network is a large bottleneck to what we are trying to do computationally. So
Right.
sending the least amount of data possible. And so approaches that we can take in this case is to process in the browser if the data is local. WebAssembly is actually an advantage in many cases because it allows you to process that data locally in the web browser without sending it over the wire to some server, some cloud computing, or some cluster, and then sending it back. So for smaller data sets, WebAssembly can help process that data faster than it would on a server. For larger data sets, the more practical approach is to do some very computationally intensive processing on a server and then do some light processing or some just sort of assistive processing on the client side.
Mm-hmm.
But the main use that we want to first apply WebAssembly to is for these examples that works with some illustrative data sets.
Sure.
But they might not be the entire galaxy. They might just be one star or one solar system.
Yeah, no, that's a great answer. It sounds, it's a hard problem in general, so it sounds again like that's a location where folks wanted to contribute in some way. You at ITK would welcome the contributions either in funds or code or ideas and approaches.
Definitely.
And things.
In all forms.
In all forms, that's right. Yeah. So are there other items on the roadmap that you'd like to bring up?
Yeah, when we're talking about the roadmap for ITK, the future for ITK, we should definitely talk about the upcoming release, which is ITK 5. Mm-hmm. It's currently in the release candidate phase, and it's a major upgrade to the toolkit. In ITK 5, the entire code base was modernized in style and updated to modern C++. And multi-threading underwent a major refactoring. There's 3 different threading backends now, including a native thread pool and threading based on the Intel threading building block, TDB library. It's much easier to write multi-threaded code in ITK 5. Mm-hmm. And ITK 5 will feature drastic improvements to the Python API and the Python coverage of the toolkit.
Wow, that sounds, yeah.
For the modernization.
That sounds huge.
Yeah, did you target a particular standard like C++ 11 or 14 or 17?
Yes, we're targeting C++ 11 for ITK 5, and that is a big step forward. And most of the compilers support that now. So. Yeah.
No, it's huge, and bringing a large code base up to that standard is a real effort. Just out of curiosity, about how many lines is ITK of C++?
There's about 1.7 million lines of C++ code.
Nice.
And and that modernization, I think it touched at least half of them.
Yeah.
So,
yeah, but also this project is 20 years old this year, so.
Right. Yeah. Almost as old as the previous C++ standard. So. That's great. That's amazing. So again, sounds like once this release candidate or gets released out into the world, you'll need help just by people using it and banging on it and telling you kind of what works and what doesn't as well.
Exactly.
Right? Yeah.
Exactly. We'll be making it work according to how people want it to work after that.
Yep.
After it's out. So the release candidate is available now. You can install it. Python pip install --pre will give you the release candidate packages, and we're encouraging people to try it and give us feedback.
Yeah, that's excellent. And are there other things either you, Beatrice or Matt, want to mention on the roadmap, or David? Any other questions?
So I think what's most interesting is more developments that are just coming from the community and the community contributions. We're very excited to see what all the new community members are bringing that will make the next big impact in ITK and in the open source community. With ITK 5, we're also making it easier to distribute new algorithms developed with ITK's architecture. So we have a Python cookie cutter template that scaffolds out the module infrastructure for a new ITK filter.
Yeah, that's excellent.
So we added new infrastructure. Now you can build with continuous integration testing and continuous deployment Python packages and deploy them to the Python package index. So looking forward to see what new people in the community will bring and what new filters and new algorithms they're going to develop and share with the world.
Maybe among this audience.
Yeah, I hope so. Definitely hope so. So I think that is about it for the roadmap discussion. And yeah, just to stress again, it's a place where these items and others and are areas where you can jump in and help out either via funding or with your code contributions, etc. At this point, we have had a couple of questions be asked, so we're going to dive into our Q&A section. So for our first question, Pablo asks, are there any interesting modules contributed recently to ITK by the community in particular?
Yes, there are. I could note one that I think Pablo contributed.
This is a fishing trip, I see.
So thank you for asking, Pablo. So we have a very exciting wavelet module, wavelet processing, filtering module for images. I think this will attract a lot of our signal processing potential customers and potential audience and contributors. For those of you, wavelets are just a very effective mechanism for detecting filaments in images and detecting artifacts and signals. So yeah, I think that one is very exciting specifically. Yeah.
Excellent. And Matt, did you have any that stuck out to you?
The most interesting one, or one of the many interesting ones that came recently, was the Reconstruction Toolkit. That's kind of an open source project based on ITK that's been developed for many years now, but they now have Python packages, and it's algorithms for reconstructing computed tomography images or these types of images. And tomography is used in many different applications and many different imaging methods. So that's where you have the projection in different planes, and you reconstruct from the projections. And they have compressed sensing iterative algorithms that are very powerful in that module.
Yeah,
it's awesome.
Very cool. Christoph asks, how well are ITK and VTK aligned in terms of compatibility and integration, when they're installed together via pip, for example? And will this change or improve in the future?
So ITK works very well with VTK, the visualization toolkit. They have a history of being developed together. And Python packages for the visualization toolkit have recently been deployed and developed in Conda and on PyPI. And in the near future, we're looking at distributing Python packages for the bridge. There's a bridge between ITK and VTK that you can convert data structures from one to the other. And there are some alpha, beta quality Python packages available in PyPI now that are improving. And over the next few months, we're hoping to harden those a little bit. They're available for Linux and Mac, Linux and Windows, and Mac is coming. And those allow you to create pipelines that process images with ITK and then visualize them with VTK.
Excellent. JC asks, I thought ITK was for image processing only. What is used for the visualization part of the widget?
So the visualization is happening in your web browser with the Jupyter widgets. And that's happening with using the WebGL technology that accesses the GPU.
Oh, interesting.
In your browser. So that's why it's so fast and responsive and 3D. And the library that's built on is called VTK.js, which is a port of the visualization toolkit into JavaScript and OpenGL and WebGL. So
fascinating. So it's sort of using some version of VTK, just the JavaScript version.
Exactly.
Yeah. Wow. Great question, JC. Thanks.
Piero asks, when processing the 3D images with various image processing algorithms, is there a risk of producing computational artifacts to the visualized image that could be misinterpreted by a viewer?
That really comes to a research design question. I mean, you need to really understand what various image processing algorithms will do to your image and what are your inputs, what are your outputs. I think thanks to the excellent documentation of ITK, when you come in for a certain algorithm, you will be able to easily understand what the algorithm does. And also, if you are using an algorithm and you see that the inputs or outputs are not what you're expecting, you're encouraged to access our discourse forums or contribute to the documentation to clarify so things are better understood. But of course, there are always risks that could be misinterpreted by a viewer. But I mean, if what Piero is coming to is, could we potentially damage potential users or patients that are that are diagnosed or something like that? I think that's a very long discussion, but there are ways in place to correct everything. Medical image processing is another medical device, so it's all regulated by the FDA. So before anything could reach that end, it will go through exhaustive review and code, software input, output, segmentation, and so on. So the short story is, yes, it could, but thanks to our documentation and our user support, it should not be too bad.
When developing a pipeline too, I think it's helpful to use these Jupyter tools and inspect along the way and understand what's happening at each step of the process. And that's a very good way to change it from a black box pipeline into something that you understand what's happening along every step of the way.
Thank you.
Excellent. So we have another question from JC, who asks, Pablo talked about module contribution. How easy is it for a user to contribute their ITK module and have it pip installable?
Good question. So as we were discussing before, we have a cookie cutter that you run basically 2 Python commands, and that will create a folder that has everything you need to create a GitHub repository. And you create that GitHub repository. Soon you'll just enable Azure pipelines, and the output will be Python packages that are automatically pushed to the GitHub releases and the Python package index. And you can do that on your own. We encourage everyone to ask on the discourse forum and become part of the Insight Software Consortium GitHub organization, which is where kind of the community gathers and puts all these repositories together. And you can develop your repository in that GitHub organization. And also too, after you create a module that has your functionality in it, your classes that you develop, we can create a pointer to that in the main repository. We put a file that allows you to see anyone who downloads the main toolkit, they'll see a link, an option to enable your module in their build. So that's kind of how these modules are integrated from the community into the main toolkit.
Awesome.
Piero asks, are there tools in ITK for visualizing tensor fields?
So ITK supports images. The images that it supports are scientific images. So not just the images on your camera, which are unsigned char, 8-bit images or RGB images. It supports many cooler things than that, which are multi-component images. So an image that contains vectors, and an image that may contain tensors. So examples are diffusion tensor imaging and MRI, and other types of content on the pixel. And right now, the Jupyter widgets, for example, they just support scalar valued images, but in the future they may support tensor-valued images, so multiple components. There's issues out there to hopefully add multiple components. That's another thing we can do in the future. And if you want to look at, so tensors, we have a first-rate tensor is like a vector. A second-rate tensor is like a diffusion tensor. And there's other tools out there in the ITK community. It's a very broad community and many applications out there. Like 3D Slicer is one of the applications that's built and supports ITK, and you can visualize diffusion tensors in that application.
Excellent. Yeah, it sounds like another great place for people to dive in and contribute either funds or their thoughts and code. Now it is time for our world famous rant section, where we each get 15 seconds to rant about a topic of our choice. Matt and Beatrice, it is your soapbox.
For my rant today, I'd like to rant about the respect and the resources we give to build and packaging tools in our community. I know John Christoph, who asked some questions earlier, he works on a package called Scikit Build, and he's very passionate about it, but I think we need more people to be passionate about it in the same way. So we've made many strides in Python packaging, for example, with Linux Python packages. But recently, there's been this update in the community. We've been working towards this Many Linux 2010 image. 2010 is a while ago now, but this is more recent that we're trying to hit again and make that part of the Python packaging equation. And it's taken a while, and I think if there's more funding allocated to Python packaging issues and developers valued the dirty work done for packaging, we would all be better off.
Hear, hear. Beatrice?
Well, I'm going to rant about peer review. And this comes down to many different levels. So only thinking about funding, we have to go through peer review for so many things in scientific computing and biomedical imaging. So I always get a little frustrated because peer review is a bit tainted in the sense that people that review your work has been reviewed by other people first. So we have this vicious cycle of somebody got asked to do all these extra things to get their work accepted, funded, whatever. So instead of, I feel like those people that went through peer review in the past will review you in the future, and you have all this extra work that they require to do, and they might review your work and be critical in the same way others were critical to them. So I don't know. I think it should be like code reviews. So if it works, it works, and if it doesn't, it doesn't. So less anger, more objectivity. And this is, I guess, what I want to say here.
Yeah, less anger is always a good thing.
Yeah.
Yeah.
Don't be angry.
David, it's your soapbox.
Well, recently I was trying out the Conan packager for C++. I just wanted to kind of get some experience with it, and I struggled. And primarily, it was in particular trying to get Google Test to run, and it all came down to compiler option. There was a bunch of tough searches through Stack Overflow and other ones to find out exactly why I was getting this weird template error, but only for Google Test, not for the example project. So I don't know. I'm sort of complaining about compiler options, but I'm maybe just more complaining about the Tower of Babel that I built trying to use different C++ compilers with CMake, with Conan, etc. I don't know if there's an answer. I just wanted to complain.
You feel your pain.
Well, the 2020 presidential election has started. That's it. That's my rant. And that's all the time that we have for today. Thanks for watching. Thanks for listening. You can find us on Twitter at Quansight AI. If you're interested in funding open source projects, including ITK, you can find all of the project roadmaps at quansight.com/projects. Beatrice, where can people find you and ITK?
So they can find us in the discourse forum and the discussion list. So discourse.itk.org. See you on the web.
Excellent. And join us again for our next discussion, because you've got our name, and next episode we've got your number. Thanks, everybody. Bye-bye.